me and Tavian have come study, so
What the boys are saying.
they're waiting on the link, and my WhatsApp is loading.
You waiting the link for?
The link to come on.
You said only on Telegram. I don't know.
Huh?
You said you're on Telegram. Telegram is waiting for the link.
Yes, sir.
Oh, that's wrong. Send it by WhatsApp. I'm not gonna be long today. Just gonna say. You're gonna use measurements in there. Use measurements and then.
So I already get it.
It's there today. All right. Until get cracking. So start anytime now. Again, so it's going to set up.
So somewhere area just low, that lower than usual.
No, you're not hearing me?
Yes, but you're not so lower as usual.
Oh, let's start. Let's start. Let's start. Let's start. No. Then. Let's go. If we can share the screen. Yeah. I would some technical here. Second. Yeah. theme song, and then we'll say a prayer before we start.
I love you, Lord. Oh, your mercy never fails me. And all my days I've been held in your hand. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. Oh, your mercy, 'cause all my life you have been faithful. All my days I've been held, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You will lead me through the fire, and in darkest night, you were close like no other. I've known you as a father, I've known you as a friend, and I have lived in the goodness of God, yeah. And all my life you have been faithful. Oh, and all my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God, yeah. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid.
All right, so good night to everyone. So we just want to pray. Let's listen to our theme song there. We want to pray good night to Giovanni Stevenson. Stephenson. Sometimes I have a problem with that last name, but yes, good night to you all. Welcome Kimura back. All right, good night again to Lloyd and Tavian, and of course, Lexi, of course, and good night to those persons who are watching us on our YouTube stream. So we're now part 3 of 4 sessions. So we'll be doing our final session tomorrow night, tomorrow evening, and of course you rest on Tuesday. And we wish you all the best on Wednesday morning at 9 a.m. and 1 p.m. We will come back again though, to work on paper 3 for those students who are doing paper 3. All right, so without any further ado, let us invite the presence of God in our virtual space to give us not virtual assistance, but his heavenly assistance as usual. Let us pray. Loving Father, we give you thanks, dear God, for allowing us the opportunity to live even until this moment. Dear Lord, is our grand exam coming on Wednesday, dear God. And these students are here tonight for the support. Lord, it's not they should be seen or hearing, but you, oh God, they should be seen and hearing. But I will use this as a vessel to give up service on your behalf and for them. I pray, dear Lord, that you will help them to develop the mental power, the physical power, and the spiritual power, hormones that they need to deliver true education, to deliver the performance that is necessary on Wednesday, dear God. Pray not only for them alone, but for students who are watching us live on Zoom, on YouTube, and students across the Caribbean. Be with us now, we pray. In Jesus' name. Amen. All right, so of course, it's going to be a shift in what we were looking at the 2019 exam paper, but there's a bit of shift that I'm making. Oh, let's say, unfortunately, no rest on Tuesday. Well, I hope you'll be able to get the rest somehow, but we'll see how that fits in. All right, so the shift that we're looking at for tonight, we'll be looking at the syllabus. Let's use the syllabus, and we'll be looking at measurement, measurement objectives, and of course, see or to see how it works. And if you feel like it's working, they will continue with it tomorrow, and then of course, might bounce around some more type of thing. All right, so I'm looking for the measurement objectives. And that area tend to give persons a lot of headache. So to reduce the headache, then here we are reducing the headache at this point. All right, so I'm trying to go ahead and maximize the screen. After that, doing YouTube. All right, so what I ask you, please mute your mics unless you are speaking to me. All right, please mute your mic. Giovanni, Giovanni, could you mute your mic? Right. Well, here we are. Looking at the measurements objectives, and this area tend to, we came off some measurement questions earlier. And of course, we saw that it was a bit difficult in some sense. And those questions tends to be a bit challenging for students. So we're going to go through the objectives, all right? So the first objective state that you're supposed to calculate the perimeter of a polygon, a circle, and a combination of polygons and circles. Now, of course, the combination part, I think, tend to be where the difficult part, the difficult questions come from, right? The combination. Now, if you want to calculate the perimeter of a polygon, can somebody tell me how you calculate the perimeter rather of a polygon? Can somebody tell me how you do that? How do you calculate the perimeter of a polygon? Anyone?
Add up all the sides.
Add up all the sides. Okay, that's one the easy one, eh? So how do you calculate the perimeter of a circle?
Basically, you're finding the circumference. That's
Okay.
2 pi r.
Pi r or pi d. Okay. Wow. Is who talking? You? All right. Now, if you have a combination of polygon and circles, what are some of the possible combinations you think they can have where a polygon and a circle for you to find the perimeter of it? What are some of the possible combinations you think they can have? And how do you go about finding the perimeter of such a combination? Before you answer, those who are in YouTube, you can in fact give your responses in the chat, and I will acknowledge you as well. You can state which country you're from, and if you're from another country different from Jamaica, please state. If you are from Jamaica, you could state which parish you're from as well, if you're not a CDPLABS student. But welcome to everyone. So we want you to participate, we want you to give your responses in the chat as well. Yeah, so go ahead, students in Zoom. I have 5 students here now. So could you, again, so we're looking at the perimeter now of the combination of a polygon and circle. What are some of the possible combinations that you could give us, and how would you go about finding the perimeter of such combination? Anyone?
So you find that the perimeter of the polygons separately, then add them.
All right, so you find the perimeter of the polygon separately and add them. But what if all right, find the perimeter of the polygon separately and add them. But remember, they are combined. They are combined. Could you think of such a polygon that you have a polygon combined with a circle? Could you think about it before I actually draw one? I want you to imagine one for yourself before I actually draw one.
Yeah, but one in there.
Go ahead. Go ahead. Didn't hear that one. Anybody think of one?
Sir, one
A cone. All right. That sounds more like it. A cone. Good. So we could have a cone. And what are the shapes a cone have? Here it is. We could have a cone. So to find the perimeter of a cone shape. See, cone. So how then would you find the perimeter of that cone? Very good. What are we seeing? How do you find the perimeter now of that cone shape? So this is where we're talking about combinations. Well, of course, you can see the. Yeah, go ahead.
And the circumference same way that alone.
Sir, as Lexi said, sir, you could find the perimeter of the triangle different from the semicircle, and then you find the circumference of that circle above, sir, and then you add them together. Um, just doing it.
All right, all right. But if you were to separate the two shapes, Javon, you recognize that this line would have been calculated in the perimeter, but this line is not a part of the perimeter of the combined shape. This midline is not a part of it. So to separate it now, that you get into problems right here. Understand now?
Yes, sir.
Good. So what I would then do, if we're using the cone shape, what I would then do is to find the length of the arc and then add it to the two lengths, which is the radius right here. Make sense? So you have to be careful of separating them. You might run into trouble. Good thing. But the idea is though, is that you know how to find, because the circumference would evidently be a part of such combination. Good? The circumference would evidently be a part of such a combination. All right, so we have Maxine Adams from St. Elizabeth. Welcome back to our channel, Maxine Adams from St. Elizabeth, parish of St. Elizabeth. Maxine, I hope that you share the link with your friends and family who are doing exams Wednesday. I mean, I think they would love this segment of our presentation tonight. All right, so we're going to move on to objective number 2. Calculate the length of an arc of a circle. How do we calculate the length of an arc of a circle? Anybody knows? How do we calculate the length of an arc of a circle? Anybody else? What would you do?
Repeat.
Yeah, how do we calculate? How do we calculate the length of an arc of a circle?
They would put the angle over 360 and times it by 2 pi r.
All right, very good. So we'll put a given angle. We'll put a given angle over 360 and calculate it by 2 pi r. Give me a second there, please. 1 second there.
But how?
Where is Alexi?
Yeah, so how would I know that the degree of the angle?
All right. You were asking a question. Go ahead.
So how would I know the degree of the angle, the part of the cone?
All right. Okay. All right. So okay. All right. What are you saying again? What was the question? Go ahead. What was the question?
How would we know the degree of the angle?
Oh, how would you know the degree of the angle? Well, obviously the question would have given it would have been given in the question. It would have been given in the question. That's how we would know.
I thought about like in the example where I use
That we are using now?
yes.
No, man. Remember, no, we're not looking at a specific question. No, we're looking at the general way. The general way of finding the length of an arc of a circle. And as Tavian just explained, that you would have placed a given angle over 360 and multiply that by 2 pi r. That's how you'd actually find the length of an arc. So whatever angle that you're actually given. So that means that you'll be looking for that particular angle. And then you write it as a fraction of 360 degrees and then multiply it by 2 pi r or pi d, which is 2 pi r, of course, is the circumference of the circle. All right? Because remember now that the length of an arc is really a fraction of the circumference of a circle. All right, so let's look at number 3 now. Another question on it, and that was a good question, Lexi. Another question on that? Another question? No question. All right, good. Let's move to objective number 3. It says calculate the area of polygons. And there are different polygons. You have the rectangle, you have the square, you have the parallelogram, trapezium, the rhombus. You also have and a circle. So we know to find the area of a circle, right? What's the area of a circle? What's the area of a circle?
Pi r squared.
Pi r squared. Okay, and of course we know that these formulas are actually given in the exam, so there's no need to burden yourself to try to memorize them before the exam. No, that's not necessary. And we need to find the area of a rectangle, length times width, and the same thing for the square. What about a parallelogram? How do we find the area of a parallelogram? How would we find the area of a parallelogram? Anybody? How do we find the area of a parallelogram? Anyone? How do we find the area of a parallelogram?
Sir, base times height.
Base times height. Okay, so base times the perpendicular height. All right, good. What about the trapezium? How do we find the area of a trapezium? You know what a trapezium looks like, right? Eventually, I have an idea what a parallelogram looks like as well. For those persons who don't have an idea, I believe you have an idea, but just not take it for
What
granted.
To the answer? Yeah.
Parallelogram looks something like this. Yeah, it's really like that. Let's try to let's clear that. So you have parallel sides. So do something like that. So let's erase the other ends. I have a parallelogram. I have the perpendicular height right here, which is multiplied by the base. And that will give you the area of the parallelogram. All right. What about the trapezium now? How do we find the area of the trapezium? Go ahead. How do we find the area of the trapezium?
A plus B times height over 2. Answer?
That's correct. Parallel sides, the sum of the parallel sides, A plus B, times the height divided by 2. All right. Or you could divide the sum of the parallel sides by 2 and then multiply it by the perpendicular height. All right. Very good. What about how do you find the area of a rhombus? How do you find the area of a rhombus?
Um,
Go ahead.
so do you multiply the two diagonal sides?
How would you do that?
Huh?
How would you do that?
I was going to ask you if I said, because I don't quite remember.
Oh. What does a rhombus look?
It kind of look four-sided polygon where it kind of resembles one diamond.
Then you have diamond.
Yes, sir.
Is it?
Hmm?
Well, yeah, you're right. Diagonal side, the square of the diagonal side, because a rhombus is like a square. It's like a square. That's what I was expecting to tell you. It's half the product, so it's really half. So you multiply the diagonal sides and divide it by 2. That is how you find the area of a rhombus. Good question. So the area of a rhombus is the product of the diagonal sides divided by 2. Remember that. The area of a rhombus is the product of the diagonal sides divided by 2. Right. No, and of course the diagonal sides are equal. So you find the product of them, then divide by 2. How do we find the area of a circle? How do we find the area of a circle?
Square.
Good. Now, in terms of the combination now of polygons and circle, what I think you said something to this effect now, which will work with this one. How do we then find the area of a combination of any of these? How do you go about finding the area of a combination of any of these? How do you do it?
Sorry, repeat.
How do you find the area? How do you calculate the area of the combination of any of these stuff? How do you do it? How do you find the area of combinations? How do you find the area? I think you did say it for objective 1. Whatever you said for objective 1 is that they need to do for, so they need to do for this one. So what do you do? What if you have this shape? Then we have the circle with it now. How do you find the area of a shape looking like that? You can identify the shapes that are there. Can anybody identify the shapes?
Sir, can I see one triangle and stuff with all of that?
All right, so you see a triangle, okay, there,
A square.
a rectangle. Rectangle.
But it,
How do you
rectangle,
for that area of the combined shape?
trapezium,
Trapezium. What? Yeah, trapezium and what is there?
and the semicircle.
Semicircle. Come on, man, use your eyes and look and see.
Sorry, I said that a long time. I first thing that I said.
I didn't hear it, that's right. All right, so therefore, how do you find the area of this combination of shapes? How do you find the area of combination of the shape? How do you find the area of the combination of the shape?
Um, it says the same thing as objective one, so
How do you find the
you find the area, the sector.
area of what sector? I mean the area of the semicircle and the area of the trapezium. You did that, and the area of the two shapes
Yeah.
together. Come on, Lexi, my sleep on, man. That's what they say. That's what you said earlier. Because you don't separate the shapes and find the perimeter of each and add it. That's what you said. But the mistake you made in that situation now is that you have the middle line that you cannot use in it. But in this case now, you can find the area of the trapezium plus the area of the semicircle and add it. So you have to be able to see it again. All right. Good evening, Ms. Evans. Nice to have you again tonight. You missed out on some of our sessions that we have had. I don't know if you saw the message in the WhatsApp group, but nevertheless, they are on our YouTube channel. So tonight, what we're looking at, we're using the syllabus to guide us now in going through some objectives that you possibly will be testing on for measurements. And if there's time, we can proceed further with other units in the syllabus. All right. So we start off with measurements because persons tend to have issues with measurements and so forth. All right. So let's proceed further with this. So we are going now to objective number 4. How do we find the area of a sector of a circle? Anybody? How do we find the area of a sector? How do we find the
Sir,
area? Go ahead.
would it be the same way you find the area of an arc?
I don't understand. Explain.
Would that be the angle over 360 times pi r squared? Oh no,
That's
not 2 pi r.
That's
I
good.
thought
Pi r squared. You have to be careful when you say the same thing because there has a difference. One is a circumference and one is the area, right? So that's why I said I didn't understand. So you have to be specific. So yes, you put the given angle over 360 degrees multiplied by pi r squared. So that's correct. All right. So number 5 now. Calculate the area of a triangle given 2 sides and the included angle. That's a given. You have the formula given there, half AB sine C. So it's just given right there. So make sure that you look at the shape you are given to find the area of, and if it's a triangle where you have the 2 sides are given and the included angle, you know exactly which formula that you're going to be using. All right. And of course, sine C, the C would have been the angle itself, and then the 2 sides would have been AB. All right. Good. Now let's move on to number 6. Can someone read number 6 for me, please?
Calculate the area of a segment of a circle.
All right. How do we calculate the area of a segment of a circle? How do you do that? How do you calculate the area of a segment of a circle? You want to draw a circle, and then you draw a segment, and then determine how you can be the area of the segment of a circle.
So you draw the circle, then you find the area of the triangle, then you find the area. What? So according to Google, right?
According to Google, I don't want to use Google. Oh, I tell me, use your imagination and tell me. I didn't ask to Google anything, you know, but all right, if you're Googling it, fine, no problem.
So I never know that one.
All right, according to Google, go ahead. Let me hear you.
So them say you find the area. So you basically draw a circle and you find the area of the triangle within the sector. And then you find the area of the whole sector, then you subtract the area of the triangle from the area of the sector.
Very good. That's correct. So you find the area of the triangle of the sector, and then you find the area of the whole sector, and then you subtract the area of the triangle from the area of the whole sector. Then I find the area of the segment. All right, good. So Google help you with that one. All right. But this is why I didn't want to use Google though. If you were to draw it for yourself, you'd have seen it. But the type of triangle though, for that specific segment would not be a right angle triangle. It could be an isosceles triangle, or it could very well be an isosceles triangle most part. So you have to then determine which formula for which triangle to use, and there's a formula for it as well, right? Which is not the right angle triangles. All right, good.
I have a question. Them formula you dip on the formula sheet?
They look on the formula.
Huh?
Yeah, man, it's on the formula. If the area of a particular triangle, yes, it's on the formula sheet.
Okay.
All right, so let's move to number 7 now. Estimate the area of irregular shaped plane figures. What do you mean by that? How do you estimate the area of irregular plane figures? How do you estimate the area of irregular plane shaped figures? How do we do that?
Cut it up into pieces.
Come again?
Put it into pieces.
All right. So they'll actually give you a graph and a little figure around it. And you just count the whole pieces, not the piece, the whole pieces. And it has an estimate. So you count the whole pieces and you come up with the answer. All right. Number 8. Calculate the surface area of solids. All right. And we have different solids. We have the prism, we have the cylinder, we have the cone, we have the sphere, we have the cube, and we have the cuboid. Now we have hardly see the sphere, we hardly see the sphere, and we hardly see the cone. So if I were you, I'd pay close attention to the ones that are not popular, because most times that's what take you by surprise in the exam. When you look at the ones that are, we tend not to focus on the ones that are not popular. So then, if you want to Google find, in this case, how do we find the surface area of a, let's begin with a, let's start off with the cylinder. The prism is very easy. All right, let's start with the prism. How do you find the surface area of a, let's see what you have to say. How do you find the surface area of a prism? How do you find the surface area of the prism? And while I wait on an answer from those who are in Zoom, I'm not seeing anybody answering from YouTube. What's going on? You guys don't know the answer to that? And you can Google it too and give us the answer in our chat area. If you are new to our channel, of course, it is best in your best interest to subscribe to the channel so you can participate in the discussion that we're having on the objectives. If you find this discussion fruitful, then why not participate? All right, so back to you guys in Zoom. So how do you calculate the surface area of a prism? Think about it.
So 2 times the base plus
Yeah,
the perimeter multiplied by the height.
what was that, Lexi?
2 times the base plus the perimeter multiplied by the height.
That's a formula that you research.
Uh-huh.
That's the formula that you research. 2 times the base.
Yes, that's what I have in my
2 times the base. I mean, any other idea? How would you find the area?
so
Go ahead, Lexi.
never mind.
All right. What anybody else want to try? How do you find the surface area of a prism? Can anybody give me an idea what a prism looks like?
Sir, can you give us an example? Because I kind of can't recall.
An example of a prism?
Yes, sir.
All right. What a picture of it.
A 3D triangle.
Well, yeah, so here's the prism. Here's an idea. Here's a prism. The one right here. How do you find the surface area of this prism like this? How do you find the prism of the area of the surface area of a prism like that? How do you do that?
Sir, honestly, I don't know.
How that one go? Didn't hear how that one go?
Sir?
What you said? Javon, what you said?
I'm saying I don't know. I don't know.
You don't know. Think about it.
No.
Think about it. You see, I'm trying. When you come to my class, it's like you're in the exam same way. I don't like to just tell you the answer just like that. I want you to think as well. I want to hear what you have to say. I mean, don't feel free to make mistakes in my class. You understand? There's no foolish response. Every response is important, right? So feel free to make a response. Go ahead, think about it. Try. Think about it. How do you find the surface area of the prism? That's the question. How do you find the surface area of the prism? Okay, Makeda, good night.
Would it be the wait. So, no. Sir, we don't know. No.
Yeah, try again. Man. Kimura, you want to try? You're always quiet in my class. You want to try Kimura? Miss Campbell, you're always quiet in my class. You'd like to try? Kimura, are you there? Okay, from Kimura. Everybody want to try? Lloyd, you want to try? Dave, you want to try? Miss Evans still on mic, you see? Let's see, you want to try it too? All right, so my case is my interest is in his feelings tonight. So I'll say, okay, so okay, my case is 16 minutes behind. Okay. All right.
Sir.
Yes, go ahead, Javon.
May I look on the image? Not the image where I show you, but the image right here, so sir, the one I have the base, the height, and the 90 degrees, sir.
Yeah. Yeah, go ahead.
Um, so sir, could it be that it's,
You'd find out.
sir, you take it off. Why you take it off?
I'm not hearing. Go ahead.
No, I'm asking why did you remove it, sir? I was actually using the image in the background just now. But you
Oh, I
took it
mean
off.
this one or this one? Which one of them? This one?
This one, no, sir, the other one. The one
This?
that says human. Yes, sir.
This one here?
Yes, sir.
I prefer use that one. Okay, there you go.
All right. So could it be base times height times length over 2?
No, that would have given the value and not the surface area.
That's right.
That would have given the volume, but not the surface area. So you see why this exercise is important, right? Yes, man. I told her the shift is important. The shift is important. You don't always need to use past papers. You don't need to. Because once you know how to do whatever's in the objective, past will all come with numbers and words. All right. Yeah, trying. I love the try. I love the try. Anyone want to try again? So I'll jump in. Give another chance to think about it. I think we're having a problem. You're not understanding the concept of surface area. I think that's the problem you're having. When we think about surface area, what do we mean by surface area? Put some for the definition. What do we mean by surface area?
The top part or the base.
So that one go?
So, I don't even know, I don't really know how to explain it, but would the surface area be like that triangle? The
All right, look at
2D
this.
triangle I show?
This is all right. When you're going to find the surface area, it is wise if you draw the net of the solid. So when you open up a prism, this is what it's going to look like. See that? How many surfaces do you see on that net of solid? How many surfaces do you see, right?
5.
5.
5. Good. And what are the shapes of these surfaces?
Rectangle and triangle.
Good. So you'd have to find the area of each of the faces, each of the surfaces,
They add them up.
and they add them up. So what was given the problem here is that you didn't understand the idea of surface area, total surface area. I think that's a problem. If you had watched the measurement video, you'd have seen that I open up the net. Madam, that's why it's important that students watch my videos, because I teach it in depth, you understand, and then you make up your own solid yourself. If you did not do that practical part of the lesson, you'd have gotten yourself into trouble. See? Trouble. But anyway, moving on. So when I talk about finding the surface area of a prism, they're basically going to draw the net of this prism, and you'll recognize the different shapes that you'll end up having. Then you find the area of each individual shape, and then you add them up, and then you have actually gotten the answer. Now, I see where Maxine is saying that you add a plus b times I. No, that is not correct, Maxine. That is very much incorrect. All right. So we have that for the prism. Let's just now move from the prism to a cylinder. How do you find the total surface area of a cylinder now?
So find the area of the circle.
You find the area of
The circles and then the rectangle.
And then the
Rectangle.
part of it. Okay. But how would you find the area of the rectangle part of it when you open it up? Let's look at it. Let's look at it now. Net of a cylinder. Here's the net of a cylinder. Let's see. How do you then find the area of the net of the cylinder? Can you mention a rectangle? How do you find the area of this rectangle here? Find the area of that rectangle. That's a big question. Let's use it. Yeah. How do you find the area of that rectangle? Why do you think about it? Because yes, you will find the area of the two circles. But how then would you find the area of the rectangle itself?
To find the height by the circumference.
Exactly. Remember that, like I said, multiply the height by the what? Circumference. Exactly. So once you multiply the height by the circumference, you'll find the area of that rectangular piece, then you add it to the area of the two circles. Excellent. Right. So how do you find the area, the surface area of a cone? Let's look at the net of the cone. The secret to surface area is knowing how to draw the nets. The net of a cone. Here we have the net of a cone. Here's one. How do you find the surface area now of the net of the cone? Go ahead. Here, go ahead.
Complicated.
Sir, this look more like one sector than one triangle.
Exactly. So you must to the sector. Now the eyes are working. The eyes
So you
are
find the area of the sector and the area of the circle?
exactly. The eyes are working. The eyes are working. So you have to then.
So we remember all of them here?
Well, anyone can come, but the key is that you must learn to draw the net of it. That's the key. The cone will be a more challenging one because you have to know the dimensions, obviously. But of course, once you're able to get the length of the arc right there, right? You need to know that. You need to know the angle that is there to find the area of the sector. So you have to pay attention to the details that actually give you in the exam, right? Now let's move now to the sphere. How do we find the surface area of the sphere? Let's say we have a net for the sphere. I've never seen the sphere coming to the exam like that, but let us see. It's good to have an idea. You'll never know. I don't think they're going to give you the sphere, so you better pay attention. I wouldn't think they would give you the sphere. They would be wicked to do that, right? They're wicked to do that, don't it? They're wicked to do that. I wouldn't bother think about it. Leave that one alone. Never see that one come. And of course, the cube and the cuboid, the same idea as a prism. All different is the shape. The shape will be for the cube, all squares. For the cuboid, you'll have rectangles and maybe two squares, right? So you basically, the idea is that you should draw the net of it and you find the area of the various shapes on the net and you add them up and you get the total surface area of each solid. All right? Everybody understand that now?
Yes, sir.
Okay, wonderful. Do you see the significance of me using the syllabus? You think it's better to use the syllabus than the past paper? Anybody? So I get a feedback before we go any further? Any feedback?
Yes, yes, sir.
I didn't hear that.
Huh?
What was that, Lexi?
Yes, sir. If you see the significance of using the syllabus.
Yes, using the syllabus instead of the past paper. Does it make sense?
And I said, yes, yes, sir.
Okay. Good. I think we'll get more covered right here because we're able to do the calculation, respective objectives. Then what you need to do is identify whatever is in the question. Good to go. Right? So give God all the glory for that. Now, of course, getting the volume of the solid is quite easy. The formula is there. If there was combinations, you know exactly what to do in terms of combination. So this is not very difficult. Now, when we did a question earlier where the volume, of a prism and of water, let's say water had some, there's a prism with water in it, and you put that water into the cylinder now, and then of course you know that what the volume is the same. You ask to find, they can ask you to find. Let me teach you about something here before going any further. The key to formulas. If you are given the volume of something, and there's area times height, and you're asked to find either area or the height, then you know that you have to just transpose, right? If the area of a circle, you have pi r square times height, and they ask you to find the radius, then you know that you're going to have to now do some square root situation to find that out. So if I were you, I'd practice to find the area, the radius given the volume of a cylinder. Practice this so that when you get into the exam, if it should come, you don't have a problem doing it. Word to the wise is sufficient. Word to the wise is sufficient. All right. But otherwise, the formulas are given and you can make use of them. Number 10, convert units of length, area, capacity, time, and speed. This is something you have to know how to convert from one unit of length to another unit of length. Meters to centimeters, centimeters to kilometers, etc., and vice versa. The area, we were doing something like that earlier too, with a measurement where you convert from square centimeters to kilometer square as well. And I showed you how to make up a question to find that out. The capacity now is changing from different, maybe from cubic centimeters to liters. Normally divide by 1,000. So cubic centimeters to liters, that's the most common one. Time and speed. Of course, if you're converting time, it obviously going to be converted from days to hours, hours to minutes, minutes to seconds, vice versa. Should be able to do that. Speed, meters per second, kilometers per hour. So there is a combination of distance and time. Good. All right. Now, objective number 11 now, use the appropriate SI unit for the measurement of area, volume, mass, temperature, and time, the 24-hour clock, and other derived quantities. And you should know those things. That's nothing difficult. All right. I must solve problems involving time, distance, and speed. Now, you can be given a distance time graph. All right, let's look at what a distance time graph looks like. And then I think only 15 objectives there for measurements. So you can be given a distance time graph. Let us not ignore that. Eh? Distance time graph. You have a distance time graph. Let's look at a simple one. Now, to find the speed, you normally, I think you'd find the area of the shape, right? All right, let's look at how to use a distance time graph. How to work out speed and distance time graph. Now, if an object moves along a straight line, the distance traveled can be represented by a distance time graph and a distance time graph. The gradient of the line is equal to the speed of the object. Good. And the greater the gradients, the faster the object is moving. Okay. So in this case right here, this is the gradient of the line. You can use this to find this, the actual speed. Good. Everybody get that? Everybody get that? Everybody not answer that?
Yes, sir.
Alright, good. Alright, so you can spend, so I guess you would have to spend some time looking at distance time graph. Maybe you can watch some other YouTube videos to work on that. Don't ignore that, because you might be surprised that they come with a distance time graph in the measurement question. You know, Lexi might come and say, sir, you know you were right. So don't tell me someone was right, hey, you never do the homework. Okay, Lexi? Okay, Mother Lexi? All right.
Okay, sir.
Okay. All right. So maximum and minimum measurements, error, estimate the margin of error for a given measurement. Let's see. How do we do that? Let's search that. Eh? Let's research that quick and fast. Eh? We boil down to things you probably never did. So they calculate the population of standard deviation, and they take the square root of your sample size divided to your population. Well, they might not give you all of that, so let us not kill ourselves with that either. But you can go and do some YouTube videos for that in particular, and so that you don't lose out on anything right there. Using maps and scale drawings to determine distance and areas. We looked at that in a question earlier, right? So you know you have to, if they give you the actual length on the map, you know you convert from centimeters to meters. Well, it's not complicated, not really complicated. Just have to do the research. So you only have to research objective 12, 13, and maybe 14 if you want to. 14 is a video for 14. You can go on our channel and find that. But when you're doing scale drawings, you know they give you the ratio 1 to so and so, and then you can now convert the centimeter given to meters, and then from meters to kilometers. Well, you have to first multiply rather the centimeter by the big number there, and then you convert to meters, and from meters to kilometers, and then you get an answer. I think it was Lloyd who explained that earlier today. So solve problems involving measurement. So basically, this is as a practice objective, right? So we finish with measurements. How was that? How was that?
Hard.
Yeah?
Hard.
Hard? Oh man, that's a picture of that. So what you would have to do when you guys are revising, do the same tonight. Do the same thing. Go through the syllabus. How do I do this? How do I do that? I think if you have to write it down on a piece of paper, you write it down. Understand? But the key is once you know how to do, once you are tested on these objectives, so once you are able to, as it says, students should be able to. So once you're able to do each of these objectives, then you can combinations now. Pay attention to. All right, let's now move to another objective. Statistics is not so difficult. You want us to go to the statistics, anybody? What do you want us to go to? Functions, algebra?
Statistics.
Go to statistics objectives?
No, the algebra.
Algebra. Go to the algebra objectives. All right. I'm going to read the first one for please.
Use symbols to represent numbers, operations, variables, and relations.
Right. In a case like this now, they can give you algebraic word phrase. I saw they did it in a previous exam. They give you the word phrase and they are to just write it in algebraic statement itself. All right. That's basically what they're testing. Well, it's saying in number 2, right? So transit statements expressed algebraically in the verbal phrases, right there, number 2, basically. Perform arithmetic operations involving directed numbers. So you must be able to, this is using integers, right? The number line is very good in helping you with this one if you have a problem, right? You must know when you multiply two negatives, it can be a positive. When you multiply negative and a positive gives you a negative. When you divide a negative by a positive, vice versa, you end up with a negative as well. So make sure you know those rules. Pay attention to the rules. Number 4, perform the 4 basic operations with algebraic expressions. All right, so okay, that's not too difficult. Substitute numbers for algebraic symbols in simple algebraic expressions, and that's you are supposed to get a substitution. Number 6, perform binary operations other than 4 basic ones. Now the binary operations is something like this, like A asterisk B equal a particular formula. All they simply do is put in A where it's supposed to be in the formula, B where it's supposed to be in the formula, and then you compute. However, they might be given 3 different things, but you know when you're doing binary operations, you do 2 first, and then that 2 now become 1 and work with the next symbol. All right. If you have the practice on binary operations, you can consult your textbook and give you an idea. Now, number 7 now, you must use the distributive law to factorize and expand algebraic expressions. And if I were you, I'd practice on the various types of factorizations. I would practice on that because factorization tends to come regularly in exams. So if I were you, I'd practice on the factorization. All right? Is that clear to everyone?
Yes, sir.
Yes, sir.
Maybe what we could do now and see. You have to practice on this. How you do. While you're practicing, you have a problem, you can bring it to the class and so forth. Simplify algebraic
Yeah.
fraction. Okay, go ahead.
So you trusted the topic now?
If I trust them,
Yes.
what do you mean trust them?
The topic that CC give. Yeah.
No, not really. I don't trust them. That's why I do.
Okay, that's asking.
The last time, we couldn't trust them, don't it?
Huh?
Last time we couldn't trust them, don't it? Last time, the Brazil last time I couldn't trust them.
Last time, none of them never come on there.
Exactly. So I would say never come, but it doesn't never understand how to approach it. You have to understand how to approach it. Understand? All right, so let us now move on to simplifying algebraic fractions. As the word fraction suggests, you treat it like a fraction. All right? And you need to practice on some of those. Use the laws of indices to manipulate expressions with integral indices. Right? So you know use the laws of indices. Ensure you understand that too. Solving your equations in one unknown, that's quite easy. And of course, simultaneous equation, which we looked at last night, with 2 unknowns, you can use either the graphical method, elimination method, trial and error method, and of course, you can use the matrix method. All right. Solve simple linear inequality in one unknown. We did something like this already, so you can go standard in the functions a bit, in functions. So you can go on the video to watch that. All right. So these are basically, if I were you, I would simply use my past paper questions and go through the algebra. But the technique would not necessarily work with that, right? Understand? Understand, ma'am?
Yes,
Understand?
sir.
So, so if you're looking at the measurement questions from the past, I now focus more on the algebra questions and the past. Get it now? Get it?
Yes, sir. Yes,
And
sir.
all right. Let's see if we can go through the functions and relations. All right. What in terms of what we talk about domain, what do we mean? Talking about domain. What do you mean by domain? What do you know? What do you mean by domain? Those are the x values, right? And the range is what?
Mhm.
Mhm. What is that range? Y values.
Output value.
Y values, right? And then you have to know to draw arrow diagrams as well. To be able to identify the ordered pairs. Right? The rule that is the arrow diagram is actually based on, which is the function, right?
Mhm.
Uh, okay, now you have to be able to, interpret graphs or functions. So you have to know equation of a line, y intercept, gradient, constant, etc. And of course, max and min. And I think I do a video on that. It will determine the maximum and minimum point, maximum value of a function. Right? So the curves
So you can make them video that available.
yeah, man, that video is available. It is the solution video. One of the solution videos you will see it. For maximum, minimum. The peak is the minimum, peak up here is the maximum. All right. All right. But I believe that I feel sleepy now. All right, so you have to know to find the gradient of a straight line. So this is called it, how do we find gradient of a straight line, by the way? How do we find a gradient of a straight line? Anybody?
Hmm.
How do we find a gradient of a straight line? Anyone? Yes, Japan, we know said catchy. Yes. All right. Tell you what. Tell you what. We are going to have to take on this activity earlier tomorrow. When you get home earliest tomorrow in the evening, when we get home and continue stretching because I'm getting sleepy. But you have an idea now. You can get the copy of the syllabus online, download it, and you take it section by section and question yourself, how do you find this or you find that for each objective. So we get on to the class tomorrow, you'll have an idea as to exactly what to do. But you will see the strategy working, and once you're able to meet the individual objectives under each topic, then you're good to go. Or you can choose a certain number of units out of the 10 and specialize on it so you can get the marks for those specific units. I would suggest that you practice on the algebra questions. I would suggest that you practice on the functions questions. And I would suggest that you practice on statistics and measurement. 4. And then the others will come in when you do the exam. So that's what I would suggest that you do. So sleep is killing right now. so not as young as I was before. But I just want to leave you with the ideas that you can use to test yourself, see what you know, what you don't know, right? For tomorrow, once we start early for tomorrow, then we will continue looking at the functions one itself. I will show you some strategies now that you can use the drum to set. I showed you a few, I think last night, where you can use a drum to set and figure out answers. I can also show you how to use graph paper to figure out answers as well, right? And your drum to set itself, the shiny part of it, when you do reflection, etc. All right, so I'm feeling sleepy. So I don't
So, but then you could have just fold the paper
Wait,
and reflect it.
yes, I could feel the paper and reflect it. Good. So I know you're going to do well this year, but you have to put in the work. I suggest that you use the syllabus to guide you. And then for areas that you think you need to practice on, then you move to the past papers and practice. All right? Am I making sense to you guys?
Yes, sir.
Right. So all the best in your exams tomorrow. Go and get some sleep. And after your exams tomorrow, you start the ball rolling for the maths. And I know that English language is on Tuesday, right? That's correct. Those who are doing English language, right? And then, of course, big day when we'll all get to heaven based on judgment day, right? Good.
Some of us have exam Tuesday too.
Oh, for Cape or for Sophie?
Okay.
Nice. But nevertheless, though, I think you'll be able to, once you go through the functions tomorrow, you'll do a bit of some algebra questions, go through functions, objectives, then I think we'll be okay. All right. Let's do the rest of it. All right, so for my visitors, Giovanni, how was the session? Was it meaningful to you, Giovanni? Was it meaningful?
As as all of your as all of your means,
Go, Giovanni.
sir, just as how all of the meets that I've been to, sir, just as how they have been educating and stuff like that, sir. This was the same, sir.
No, I'm not hearing it clear. Go ahead.
I'm saying just like how the other meets that I've attended, sir, just like how they have been educating and sir, fun. This one was not really the fun one, sir, but it was educating.
It was edifying.
Yes, sir.
Okay. All right. Thank you very much. All right. What about Lloyd? Or was this session in terms of not using past papers? But do you think that this part was meaningful? Lloyd?
Yes, there it was.
Okay. Well, what's the difference between this using the syllabus, right, different versus the past paper?
Sir, I think we cover more of what the syllabus expects us to know, and it's better for us because we get to think more outside of the box than what CSEC put directly on paper.
All right, good. So that's exactly what. Thank you very much for that. That is exactly what the aim is. So that means when you go into the exam, because you know you have the how in your head already, you just want to use your eyes now to identify what you need to use the how on, and then you're good to go. Exam finish. All right, that is it. So I think you should spend the time focusing on the syllabus. Spend the time, and just like how Lexi would have done the research. It's something if you're not sure about, you research it. And while because you're researching it, you're processing the information. And of course, I say to you, before you go to this technique, pray first. Pray first. And let me leave a little experience with you. You know the name of the doctor. You know the doctor. You'd have heard his name called several times. Dr. Benjamin Carson, affectionately called Ben Carson. Of course, he ran for in the primaries for the Republican Party of the United States of America. He's in the Republican Party. But the issue behind Ben Carson is that he is the first Black American surgeon to separate Siamese twins at the head, are the first surgeon in the world to separate Siamese twins at the head, right? He's a neurosurgeon actually. But in terms of his life story, I mean, when he was at the university and he had an issue with chemistry, you know, his wife encouraged him at the time. And of course, you know, he prayed about it. And while he was asleep, God taught him in a dream. In a dream. So when he went to the chemistry exam, all he was to rely on was the dream. And of course, he shut down the chemistry exam. So I am suggesting to you, don't just pick up the book. Don't just pick up the syllabus. Pray first. Ask God for what you want, and God will give it to you. Just believe and leave the rest to Him. Simple. So I leave that word of advice to you tonight. And maybe that's why God wants to shut me down now and take control for the rest of the night. So take care, walk good, study well, and pray. And read your Bible too. Proverbs are good passage of scriptures to help to build your brain power. So that's what I would do on Tuesday night before I go to bed. I'll read a proverb and try to get meaning from it and just ask God to do the honors. And I tell you that you'll pass your exams. Not ask you, I'm telling you. All right? If you do exactly what you're supposed to do. Tonight, tomorrow night, and for Tuesday night, give God some of your time. All right, so take care. It was a pleasure. I'll see you tomorrow evening and wrapping up our series of classes. And of course, we'll be going live sometime next week, hopefully, for our HSB program. For those persons who are doing human and social biology, feel free to join Zoom. Feel free to come on our live. We did very well last year, human and social biology. Actually, 100% pass. Persons who joined us on YouTube passed exam as well. A few persons in other Caribbean countries passed their exams, and of course here in Jamaica who associated us. So we have the HSB lock as usual, and we take it from there. So take care. Have yourselves a good night, and look forward to have great interviews with you guys in August. Have a good night. Goodbye. All right, Kimura. All right, so I just want to say a special thanks to our 715 subscribers who have subscribed to this channel. Just by way of informing you what CDPLABS is up to for the next academic year, we are trying to work on, well, not trying to, we are working on our PEP program. We'll be looking to prepare grade 5 and 6 students for the PEP exams coming up the next exam period. So if you know anyone who's going to be doing PEP or know anyone in grade 5 and 6, you can ask, you can let them know that they can register with CDPLABS services. We'll be having great teachers to deliver that service, but we need the students before we can hire the teachers. So once they start to register for grade 5 and 6 program, then of course we can start sourcing those excellent teachers to deliver the service. Of course, we continue with our CSEC program in the areas of the maths and English, and of course the sciences, hopefully. And of course, we were looking at the sciences. Well, we're looking at the sciences from a different angle. If you're going to be an adult learner in the science, you have to get your equipment for you to do SBS from home, because we don't have a virtual lab, and therefore there are issues with our laboratory experiences. We have suffered with that so far, but we don't want to suffer anymore. So my advice to you is that you get your lab equipment so we can do labs at home for a science program. And of course, if there are high schoolers who are doing those subject areas, then those high schoolers will do well being a part of our science program. Of course, the business subjects, we'll be looking at POB, accounts, and EDPM. And if we can find a number of IT students, then we can find an IT teacher. Now, for our art program, we'll be looking at, for the art program, we're preparing students to do art exams in the areas of accounting clerk, level 2, and of course in the area of business administration, but specifically secretarial skills, level 2. And so therefore, we have those programs lining up for the next academic year. So if you know if anybody's interested, look out for our flyers and you can pass it out, share the links so persons can participate. Of course, you know that our rates are usually the best rates. And of course, our service, the more students we have, the more teachers we will have, and the more the service will be as great as it was years ago and continue to be great. So thank you for supporting CDPLABS Services. So on behalf of the staff of CDPLABS Services, I want to wish you a good night and all the best in your exams. Take care. Have yourselves a good night.